In this video, we're going to be looking at multiple types of probability problems, but they're not going to be very clear on what formula to use. And we're going to have to decide which one of these four formulas we have to use to solve a given problem. Those are four types of equations. So let's look at our first example and see how we can apply one of those equations to solve it. So here we go. The probability of Sam getting an A on the chemistry test is 0.76. So before I get anywhere, every time I read a sentence and I'm given a probability, I like writing it down. So let's write the probability of chemistry, and since we're doing chemistry and calculus, I don't want to use C, so I'll use the second letter H. So the probability of chemistry is 0.76. Then we go on, the probability of him getting an A on his calculus test and an A on the chemistry test is 0.494. So this one is an AND probability, so chemistry and calculus, and we'll use an A for calculus since that's the second letter. That is 0.494. And then finally it says, what is the probability of him getting an A on his calculus test given, and that's a key word there for that conditional probability, that he got an A on his chemistry test. So the probability of calculus given, that bar for given, that he got an A on his chemistry test. That's what we're solving for. So we go over to our formulas here, and if we look at each of those formulas, the only one that has a formula with given in is this dependent formula. So that's the one we're going to use. So we're going to put our numbers into that formula. So we have that AND part. Let's change colors here. So we have that AND part. That's H given, or H and A. So that's what we're going to put first, 0.494. That's going to be equal to the probability of event A. Well, that's going to be 0.76. That single probability there. And that's times the probability of B given A. Well, there is my given probability, A given H. So that is my X. Now to solve this formula, all I need to do is get rid of that times 0.76 by dividing by 0.76. And when we divide 0.494 by 0.76, we get 0.65. So X is equal to 0.65. So the probability of A given, so A on the calculus test, given that they got an A on the chemistry test, is 0.65. Okay, so notice again we pick that dependent formula because it's asking us to solve for a given probability, and out of our four equations, that's the only one that is a given probability. All right, let's take a look at the next example here. Next example, an optional camp to improve players' basketball skills was held in the county. The probability of a kid attending was 0.62. So the probability of attending is 0.62. Okay? The probability that they attended and made honor roll was 0.44. So the probability of attending and honor roll is 0.44. What is the probability that they made the honor roll? So here we go. Probability that they made the honor roll. That is our X. Okay, so what we need to do is we need to go look at our formulas and find a formula that has an and then two single probabilities, no givens or ors or anything like that. So let's take a look. Our first probability doesn't have an and in it, so we can't use it. Our next probability equation has the and it has 1, 2 single probabilities. So that is the formula we're using. Now some of you may ask, well, what about this overlapping one? It has the and it has two single probabilities. But notice it also has this or probability. And since it has that, we can't use that equation because we don't have any or probabilities in our problem. So we're going to use that independent equation. Okay? We scroll back over here. Using our independent equation as it's listed up here, we're going to take the probability of and, which is 0.44, and set that equal to the single probability of 1 attending the camp, 0.62, times the probability of making the honor roll, x. And then from there, all we have to do is solve for x by dividing by 0.62. Divide both sides by 0.62, we get approximately 0.71. So the probability of being on the honor roll is 0.71. And that's it for that one. Okay, last example here. So this example doesn't give us a word problem, it just gives us a bunch of information. So it says the probability of A is 1/4, the probability of B is 5/8, the probability of A or B is 3/4. Find the probability of A and B. Okay, so in this problem, look at all the information we're given. We're given two single probabilities here, A and B. We're given an OR probability, and they want us to solve for an AND probability. So looking at our four equations, which one has each of those things in it? This one does not have an OR probability. This one does not have an OR probability. This one does. It also has a single probability and a second one, just like our problem. And finally, it has an AND probability in it. So it has all four pieces that we're looking for. So this is the formula we're going to use, our overlapping formula. So all we have to do now is substitute in our numbers and solve. So we take that OR probability, 3/4, we set it equal to probability of A, which is 1/4, plus the probability of B, which is 5/8, and we subtract the probability of A and B, we'll call that x. So now what we need to do is we need to solve for x. So the first thing we need to do is get all these to have common denominators. So I think the best way to do that is to get an 8. And another trick here is actually to multiply by that common denominator of 8 to each number. So I'll multiply this by 8, multiply that by 8, multiply that by 8, and multiply that by 8. If I multiply every term by the same thing, I'm keeping the equation balanced, but I'm getting rid of the fraction. So 8 times 3/4 is 6, 8 times 1/4 is 2, 8 times 5/8 is 5, and 8 times 1x is 8x. Just bring down all the corresponding signs. So now we just solve for x. 5 plus 2 is 7, minus 8x. We can subtract 7 from both sides, so we get -1 is equal to -8x. And then we divide by -8. And we get that, let's bring it up here, x is equal to 1/8. So from there, we can then say that the probability of A and B is 1/8. If you want to get that as a decimal, that would just be 0.125. Okay, so again, we picked this specific formula because based off the information we were given in the problem, that was the formula that had all of that information. Okay. If you guys have any questions, please feel free to reach out and ask. What I need you guys to do is work on those practice problems that are included after the slides.